All right, so here we are to start out the chapter and to start out the first unit, which is reviewing some rules that go along with exponents and also taking a look at our polynomial operations. So I'm going to go ahead and get started, and you should, in your packet, you're going to see that you've got these skeleton notes that you can obviously go ahead and copy. And then two, if you have some questions, feel free to jot them down. And we'll go ahead and get started. All right, so first of all, some keywords that we're going to be looking at using, and one of those is a monomial. Okay, so it says a monomial is a constant, it's a variable, or it's the product of numbers and variables. So since it can be a constant term, something like -7, that is a monomial. We could also take a look at a variable. So I could do something like x to the third. That right there is a monomial. You can also do the product of them. So something like 6x squared would be a monomial, or maybe perhaps 1/2 x to the fourth, y to the fifth, anything like that. Those are all examples of monomial. Big key part to that right there is this key of mono, which is referring to 1. Now, when we're working with monomials, we have to keep in mind some powers, properties that are out there to work with. And the first one here is the product rule. So you might remember, like, if you take x to the power of n and you multiply it by x to the power of m, remember that we add those exponents. So x to the power of n plus m. So as an example, say you've got x to the third, multiplying it by x to the fifth, that would give us x to the 8th power. So remember, with exponents here, you are working with repeated multiplication. And when you're multiplying these, you're just multiplying over and over. All right, power rule, that looks like when you take a power to another power, that is when we are going to multiply. So x to the power of n times m. So say you've got x squared to the third power, that's going to give us x to the 6th. When you take something to a power, again, it's repeated multiplication. So x squared to the third power, you're taking x squared times x squared times x squared. So overall, you're taking x and you're multiplying it out a total of 6 times. Quotient rule, here we are going to be using subtraction. So x to the power of n divided by x to the power of m, that is equivalent to x to the power of n minus m. So x to the 5th divided by x squared will give us x to the 3rd. What's happening here is values are canceling each other out. As we start moving on and we start to look at some different properties that are out there, the only way that a number or a variable that it cancels in the numerator and denominator is if it is a product. And so here, since you're multiplying them all together, those are going to cancel, giving us x to the 3rd. All right, another one that we got to think about is what happens when you have negative exponents. This is one that's usually forgotten here. So x to the power of negative n, that is equivalent to 1 over x to the nth power. So when you think of, I'm going to go up to here and just say, so you had x squared divided by x to the 5th. That right there, using the quotient rule, would be x to the power of -3. And that is also equivalent to 1 over x to the 3rd, because technically you've got 3 x's that are left in your denominator, because 2 of them canceled out the numerator. And then the next one that's also often forgotten is what happens when it's x to the power of 0. That right there is always equal to 1. And reason for this is because, again, if we go back to that quotient rule, say you've got x squared divided by x squared, 2 minus 2 is going to give us 0. So x to the power of 0, which gives us 1. Why does it give us 1? Well, x squared divided by x squared, all of those x's right there, they are canceling each other out. And anything divided by itself is going to give us 1. All right, so those are our properties. One thing that I would suggest that you do with this video is go ahead and pause it and try and see if you can work out the following examples. I'm going to go ahead and do them here, but I do urge you to try and do them on your own first. All right, so we are going to try and do some simplifying here, try and condense these as much as we possibly can. So I've got negative 6 to the 4th power times negative 1/4, and we are going to square that. So, you know, order of operations type stuff here, we are going to be working with these powers. Now, negative 6 to the 4th power, when we look at that, right, that's negative, yeah. So since it's to an, oh, hold on one second. I was just looking at this incorrectly. At first I was like, why is this supposed to be, I was looking at my answers real quick and I had negative. I was like, why do I have that? Notice where that negative is. So I'm actually going to backtrack here. This right here is taking 6 to the 4th power and making it negative. There are not parentheses around the negative 6 to the 4th. It is 6 to the 4th, and then it's making it negative. So with that being said, when we take 6 to the 4th power, which is 1,296, I actually have to make that negative. So negative 1,296. Negative 1/4, here's where the parentheses are around that negative where I square it. And 1/4 times 1/4 is going to give us 1/16. And this is going to be equivalent then to negative 81 that we can simplify it to. All right, let's take a look at the next one here. First of all, I've got 5 to the power of 0 divided by 3 to the power of negative 1, all to the power of negative 2. Now, what I'm going to do right now here is I am going to take everything to this power. And since I'm doing it for a fraction, I do have to work with the numerator and the denominator, which means that we are going to take 5 to the power of 0, and I'm going to multiply that by negative 2. Divide by 3 to the power of negative 1, that times negative 2 as well. Power of a power, we multiply those. So 0 times negative 2, well, that is 0, so 5 to the power of 0, and negative 1 times negative 2 is going to be a positive 2, so 3 squared. Well, 5 to the power of 0, that is 1, and 3 squared is 9. So we are left with 1/9. All right, number 3, negative 3p squared times 8p to the 6th. First of all, you got those constant terms right there, negative 3 and positive 8. That's going to multiply together to give us negative 24. P squared times p to the 6th. I'm going to add those together, and we get p to the 8th. Number 4, we have a little bit of work to do on this one. First of all, I'm going to simplify over here on the left-hand side. I've got some division happening. 57 divided by 3, well, that's going to give us 19. X to the 4th divided by x to the 1st, so 4 minus 1 is 3, so x to the 3rd. And now y to the power of negative 2 divided by y to the power of 3. So we're going to subtract negative 2 minus 3, so y to the power of negative 5. And yep. I'm wondering on your sheet, just, I'm going to, okay, let me go here first, because clearly mine doesn't have something, but I am wondering if your answer key might have something slightly different. All right, so right now, because I've got the minus here, there's nothing that I can do further with this. That's what I'd leave you with. Now, in case your sheet has this as a negative 3, negative 2 minus a negative 3, that would turn this into a positive 1. And if that were the case here, we'd actually be able to work these. So we get 19 x to the 3rd, y to the 1st, and that's the same as 11 x to the 3rd, y to the 1st. So that would end up giving us here 8, oops, wrong color here, 8x to the 3rd, y to the 1st. So not sure which copy you guys have. That's a little something different on mine versus that one. All right, number 5, we have not much that we can do over here on the left-hand side, but you are taking a power of a power, so we do need to work on that. Negative 4 squared, so that is going to give us 16. R to the third squared, that's going to give us R to the sixth. And S squared is going to give us S squared. All right, so now we can, I'm going to put this in here. Now we're going to multiply. So I'm going to take my 3/4, I'm going to multiply it by 16, and that's going to give me 12. R to the power of -2 times R to the sixth, we add that, so that gives us R to the fourth. S to the fifth, multiply it by S squared, so that's going to end up adding there, and we get S to the seventh power. All right, number 6, we can simplify this down. We've got 18 divided by 4, so it doesn't go in evenly, but we can change that right there to 3/7. So I'm going to make this a -3/7. I can take my a's. 8 minus 5 is 3, so I get a to the, what did I say, 3 right there. 4 minus 7 then gives me -3. So this would be one way I would accept this problem. Or another option that you could do is we could do the -3 a to the third and put, or you could have that b to the third power in your denominator. Either one of those I would be completely fine with. All right, number 7 here, we have to take everything to that second power right there. So that's going to be quite heavy to work with, which actually, before I do that, I'm going to start by simplifying inside the parentheses first. That might make it a little bit easier. 39 divided by 24, so that's going to be 13/8. C to the seventh divided by c squared, that gives me c to the fifth. D to the fourth divided by d to the fifth gives me d to the power of -1. So now if I take everything to the power of 2, I'm going to get, now I do have to square the 13 and the 8, so I'm going to get 169 over 64. And then I'm going to get c to the 10th, and I'm going to get d to the power of -2. So there is one option of writing this out. Or if you would rather keep that c to the 10th up in the top, and perhaps you like working with positive exponents, you could put that d squared down in the denominator as well. All right, last one, number 8 here. I have to take everything to the third power. And here I have to take everything to the power of -2. So I'm going to take 1/2 to the third power, so that's 1/8. And then I get m to the power of -6 and n to the power of 9. On the other side here, 1/8 to the power of -2. Now, what that is going to do, oops, sorry, got all this stuff popping up, is first of all that negative, so 1/8 to the power of -2, that negative is going to flip it around. So actually, taking this as 8 to the power of 2 is the same thing. So this is going to give us 64 m to the +2, so it's -1 and -2 is positive, and I get n to the power of -8 with that part. So then now I'm going to multiply 1/8 and 64. Well, that gives us 8. M to the 6th and m squared gives me m to the -4th power, n to the 9th, and n to the -8. I add those and I get n to the 1st power. So again, there's one option, or if you wanted to do this as 8n over m to the 4th, that would be an option as well. All right, so that's just kind of working with monomials, working with those different powers that are there. The next thing is talking about a polynomial. Polynomial, when you think of the word poly is referring to many. So it's the sum or difference of many monomials. And other things that you've talked about in Algebra 2 is talking about the degree. The highest exponent of a polynomial is called the degree. That will be something very important to us later on. And when we write something in standard form, it's just written, you're writing the terms in where the exponents are in decreasing order. So write exponents in decreasing order. All right, a couple of classification things just kind of to think about. We'll use these later on. When we have degrees, okay, so for example, when you have something that's like a 7, okay, number that is what we refer to as a constant term. And in that situation, there is no variable, there is no exponent for that purpose. So right there, the degree is 0. Now, when you take a look at, say that was 7x, this would be 7x to the first power. This is what we refer to as a linear polynomial or linear term, linear equation, linear function as we look at it. And we'll talk about how those make straight lines. Well, now when we start taking a look at, say, 7x squared, now we are working with a quadratic. So you got linears with 1, quadratic is going to be referring to 2. 3, we'll be talking about a cubic function. 4, we'll see these, but I won't use the word quartic too much. But this would be something of, if you have a degree of 4, it'd be a quartic. And if we were going to 5, that would be quintic. You will hear these next terms of, like, depending on how many terms you have in your polynomial. If we have just one term, like we just saw up above, we are referring to it as a monomial. 2 terms, that would be referred to as a binomial. So something like, say, 6x plus 7, that right there would be a binomial. Well, after bi comes tri, so 3 terms would be a trinomial. We do this a lot when we're trinomials, when we're working with factoring and we're working with quadratics. And 4 plus, that's when we talk about just being a polynomial. No special names after that. All right, so what you should be familiar with is how do you add, subtract, multiply working with polynomials. We will review the division of polynomials once we get into working with polynomial functions. Just remember that when you are working with adding and subtracting, you have to make sure you're doing things adding with like terms, and just be careful with subtraction. Here I've got 1b squared plus 8b squared, so that would give us a 9. Size, here we go. So 9b squared. I have 5b plus a negative 2b, that gives us 3b. Negative 11 plus a negative 7, so that's going to give us negative 18. What's happening right here is I have 3 terms, so this is a trinomial. The largest degree is a 2, so this would be also considered a quadratic function. Quadratic expression, I should say. When you're doing subtraction, just be careful because you do need to make sure that you're subtracting everything. So as I look at this here, I'm taking 3w squared minus 3w squared. So that's going to end up giving us 0w squared. Those are going to cancel each other out. 2w minus a 7w, that's going to give me a negative 5w. Negative 6 minus 9, that's going to give us negative 15. I went from taking 2 trinomials to now this is simplified down to a binomial with a degree of 1, so we would refer to that as being linear. All right, number 11 is doing subtraction once again. Just make sure that you're really careful that you're matching things up correctly. Starting with the largest exponent, I've got 1y to the third minus a negative 3y to the third, so that's actually adding the 3, so 4y to the third. I've got a negative 3y squared, and subtracting a 4y squared. So negative 3 minus 4, so that gives us a negative 7y squared. I then have y, but I don't have any y's in the first, so I'm subtracting that, so that's going to be a negative 1y. and I still have that -2 that's hanging out there. I now have 4 terms, so this is going to be a polynomial, and its degree is third, so it is a cubic polynomial. All right, last one here is working with addition. My largest exponent looks to be cubed, but I don't have anything in the other part here, so 5k cubed. As far as k squared, I got a -k squared and a positive k squared, and I'm adding those, so that's going to cancel. I'm adding a -4k, and 7 plus 2 is going to give us 9. So we have gotten this down to a trinomial, and it is a cubic. So that right there is the adding and the subtracting part. When it gets to number 13 here, we are working with multiplying. So you'll probably remember doing some FOILing here. We're going to kind of go on the extreme end of that. But the big thing here is that you got to recall that you need to distribute everything that's in the first set of parentheses times everything that's in the second set of parentheses. So x times 2x squared, so that's going to give us a 2x to the third. X times 6x gives us 6x squared. X times -7 is -7x. Now we go on to the -3. -3 times 2x squared gives me -6x squared. -3 and a 6x, so that's going to give us -18x. And -3 times 7 is going to give -7 is going to give us +21. When I look at like terms here, I've got a 2x to the third, I've got 6x squared and -6x squared, so they're going to cancel out for me. -7x and -18x, that's -25x plus a 21. So there we end up getting a trinomial with a degree of 3, so it is a cubic trinomial. Now, what about on number 14 here? So first of all, we do need to do some FOILing on the left. We're going to distribute on the right, and then we are going to try and combine some terms here. So 4t times 5t, that's 20t squared. 4t times 3 is going to be a 12t. -1 times 5t is -5t. -1 and 3 is -3. So there's the first part. Now I'm going to actually distribute that negative because that would allow me then to use addition. -2t times 10t, that gives us a -20t squared. -2t times a -9 gives us a +18t, so plus 18t. Add some terms together. 20t squares are going to cancel each other out. I have a 12t minus 5t, which is 7t. 7t plus 18t, that should give me 25t. And then I've got -3 that's there. So this one right here is going to be a binomial. And it's got a first degree, so it would be linear. All right, so now as you get down to these last few that are here, I just want you to be very careful, especially on number 15. When you square something, probably the biggest mistake people make is they think they just are going to distribute. Not what we want to do. You actually need to expand, which means that we need to multiply it by itself. Okay, you're going to see multiple examples of this as we move throughout the year, and this is a big one that you can recognize. You have to expand, and now we have to FOIL this out. So it takes a little bit of work for us. 4j times 4j, so that's going to give us 16j squared. 4j times a -4k is going to give us -16jk. -4k times a 4j is a -16kj or jk, however you want to write it out. -4k and -4k is a +16k squared. So like terms come together. We get 16j squared minus 32jk plus 16k squared. This right here is a trinomial. And the largest exponent that we do have right here is 2, whether we would look at the k's or the j's. So this would be a quadratic. Now, as you get onto these next few and you're doing some multiplying, these are going to take a little bit of time. If you have 3 factors that you are multiplying out, you just need to start with 2 of them, take that answer times the third. 2v times 3, 2v minus 3. So I'm going to take 2v and 2v, so that's 4v squared. 2v and negative 3 is negative 6v. 3 and 2v is a positive 6v. Notice those cancel. 3 and a negative 3 gives us negative 9. So the good news right there is that that does simplify down to a binomial, 4v squared minus 9. Now I need to multiply that answer times the negative 3v. 4v squared times negative 3v, so negative 12v cubed. 4v cubed squared times 1 gives me 4v squared. Negative 3, negative 9, negative 3v, so that gives us plus 27v, and negative 9 and 1 gives me negative 9. So there we have this polynomial with a degree of 3. So this would be a cubic polynomial that we are working with. All right, so I hope that you're kind of understanding that. I do want you to know that if you do struggle with some of the multiplying, something that sometimes helps people is instead of, doing more of the distributive property, is I have people create a little table to help with their multiplying. And so here we're going to take p squared plus p minus 6, multiply it by p squared minus 2p plus 1. And it just makes sure you don't forget anything. P squared and p squared, that's p to the 4th. P squared and p is p to the 3rd. P squared and negative 6 is negative 6p squared. So you can do it this way as well to help make it a little bit perhaps easier on you, and so you don't forget anything. And I always like it at the end here too, because you can typically look diagonally and see what gets combined, and so you don't have to look too far to see that. And so we would get p to the 4th, looks like a minus 1, so a minus p to the 3rd, negative 2, and yes, and 1p squared, negative 2p squared, so that's negative 1, and a negative 6, so negative 7p squared. 1p and a 12p, so 13p, and a negative 6. Sorry, kind of ran out of room right there. So you got 1, 2, 3, 4, 5 terms, so that's going to be a polynomial with a degree of 4, making it a quartic polynomial. If you did work ahead and did number 18, just to see if you had the right thing here, you should get 9x to the 4th minus 66x to the 3rd plus 97x squared plus 88x plus 116. So there's quite a bit. It's a long polynomial right there with a degree of 4, so that would be a quadratic polynomial. Now, what you can also now do with this is you can apply things like terms from geometry and these properties to do some solving from here on out. And these are really good ones, especially when it comes to like an ACT type of question, because it's doing what you did up above and also putting a little bit of geometry together. A triangle has a base of 3x plus 7 and a height of 5x plus 1. Don't be afraid to, just draw yourself out a picture. The fact that it's giving you the base and the height, it might not be a right triangle, but by all means, you can draw it as one. A second triangle is drawn with a base that is tripled and a height that is doubled. So now you're thinking of, what did it say? Second triangle, the base is tripled and the height is doubled. find the difference between the area of the original triangle and the new triangle. All right, so remember that area is 1/2 base times height, so that is a friendly little reminder. So if we talk about the original to start with, we're going to take 1/2 of the base of 3x plus 7 and multiply it by the height of 5x minus 1. So if I do a FOIL process right here, 3 times 5x, 3x times -1, and all of that, we should get 15x squared, combine my x values of 32x minus 7. Now distribute that 1/2. So about 7.5x squared plus 16x, sorry, minus 3.5. Now take a look at that new triangle. I'm going to put this one in red, where we're going to take 1/2 of the base, which is 3 times the bottom. So let's say 9x plus 21, double the height, so that's 10x minus 2. And again, FOIL that out, and we're going to get 90x squared plus 192x minus 42. Distribute the 1/2 to go along with that. We've got 45x squared plus a 96x minus 21. Now the last part here asks us to find the difference. Okay, difference is referring to subtraction. So we're going to take these two polynomials, I'm going to go ahead and just right up here to the top, and we are going to subtract them. 7.5x and 45, which find the difference between the original and the new. And your new one is going to be bigger, so actually I should kind of flip this around. And we're going to want to take the 45x squared. We're going to want to take the new one minus the smaller one, since it got bigger. And now just working with all these like terms, 45x squared minus 7.5. So that's 37.5x squared. 96x minus 16x gives me 80x. And let's see, we got negative, oops, sorry, this is supposed to be a 21 right there. Yep. Negative 21 minus a negative 3.5 gives us negative 17.5. So there is the expression for the area of the difference. All right, so that wraps up section 1.